So Science, the company, has been around for just over 2 years. And a bunch of us left Neuralink in 2021. And we raised 160 million to develop a visual prosthesis to cure certain kinds of blindness. So let's talk about blindness. About 45 million people, or about 0.5% of the world's population, are blind. I've listed some common causes here. So in some of these cases, the optic nerve itself, that's the tissue that connects your eyeballs to your brain, is no longer intact. And short of brain surgery, there's like not much we can do about that. But in these two indications that I've highlighted here, AMD and retinitis pigmentosa, it's like the optic nerve is fine. It's only the light sensitive layer in your eye that has died. And at the end of the day, it's like your brain is not light sensitive. So all that you perceive as vision is really just electrical impulses traveling down the optic nerve. And so if we can replicate that, then we can provide vision. This is the Science eye. On the left side here, this is actually not a render. This is a device that we produced earlier this year, and it's a photograph. On the right side, this is a render. You can see what it looks like when the device is unfolded and installed into the eye. So how does this work? There's 3 parts to this device. The first part is a gene therapy. So we inject a virus to make the cells of the optic nerve reactive to certain wavelengths of light, in our case, green light. Part 2 is basically this device here, and I'm going to point out a couple features. So that gray square that you see kind of like over the retina there is an LED screen. It's 2 millimeters by 2 millimeters, and it contains 16,000 pixels. So this is about 8 times denser than an iPhone Retina display. This allows us to get down to single cell resolution. So that means when you turn on one LED, you are triggering one cell of the optic nerve to fire. The screen is connected out through the sclera to a soft electronics package on the outside of the eye. And the entire implant is actually passive, so there's no implanted battery. And so the third part of the device is a pair of glasses that you wear. It has 2 forward-facing cameras and a block of compute and a battery, and it provides power and data to the implant over IR. Cool. So turns out we're not the first people to try to make a retinal prosthesis. However, ours is a lot higher resolution than what is currently available, the current state of the art. The best FDA-approved device today has 55 pixels compared to our 16K. So you can see the difference in resolution here. I want to stress that like this kind of blocky like pixel art style isn't actually how the world is going to look like to our first patients, because brains are just like much weirder than that. But this is a way to show the difference in how much visual information you can encode into a single frame. Cool. So what comes next, like for science after this? Okay, I'm missing some stuff on this slide. There should be an eyeball pointing to the optic nerve and an ear pointing to the other one. So an obvious next thing to do, if it works in the optic nerve, is to try other cranial nerves. We think that, for example, we can make a much better cochlear implant using the same technology. And then to go really far future, there's only 12 cranial nerves total. And all of the information in and out of your brain flows through these 12 cranial nerves. And so if we can capture all of them, then in some sense, like you have a complete API to the brain. And this is like really, really cool. And come find me afterwards to like talk more about this. This is our current software team at Science. I think a very reasonable question at this point is like, what does the software do at a company like Science? And so I'll try to give some idea. On the device side, we are fabricating the Science eye all the way down to LEDs and transistors. And so the software team is building tools to help make that possible. On the bio side, we are growing our own custom cells and viruses. And this turns out to be a great fit for robotics and automation. And we're also working on a general purpose IDE for behavioral neuroscience. And kind of more than that, because I was there from the beginning, and because Max Hodak, our CEO, is himself like one of the best software engineers that I know, software has always been a first-class citizen at Science. It's one of the things that we're good at, and we have a lot to build. So if this sounds interesting, you should come work with us. We work on site in Alameda, California. Our office has a bio lab, a little foundry, and a cat room. Thank you.